today is on prime factorization. In my attempt to make it more entertaining, I've got some music. Prime factorization. Okay, so we need to remember what a prime number is. A prime number is a number with two factors, one and itself. So some examples of that would be 2, 3, 5, 7, 11, and 13. And a lot of people forget about 2 because they think that 2 is even. Well, it can't be a prime number, but 2 in fact is a prime number because it's got factors 1 and 2, so it's a prime number. The opposite of a prime number would be something called a composite number, and a composite number is a number that has more than 2 factors. So some examples of that would be 4, 6, 8, 9, 10, 12. Kind of feels like anything that's not prime would be composite. Almost. There are two kind of weirdo scenarios, and that would be 0 and 1. 0 and 1 are neither prime nor composite. Okay, so an important distinction to make. Okay, so that should be review. And in fact, the whole lesson today I think should be review because I believe you've seen this before. So now we're going to take a number and we're going to break it down into its prime factorization. So prime factorization of a number. What I want to do is I want to take 24 and I want to break it into its most basic components. That means all the prime numbers that make 24 up. So if you think about the periodic table of elements in science, water is made up of H2O, 2 parts hydrogen, 1 part oxygen. Well, 24 is made up of a bunch of different prime numbers. Those are the basic building blocks of every number. So let's take a look at how we do this. We're going to start with 24, and we're going to think of 2 numbers that multiply to give me 24, any 2 numbers. So I'm going to do, let's do 6 and 4. I take 6 and 4, and I make a little tree out of it. 6 times 4 is 24. Then I say to myself, is 6 prime or is 4 prime? And in both cases, neither one of those are prime. So I'm going to keep going with my tree. What 2 numbers multiply to give me 6? Well, 3 times 2. And I don't have any choices there. 3 happens to be prime, so I'll circle it. 2 happens to be prime, so I'll circle it. And that's kind of the end of the line there. That's the end of that path once I circle it. 4 can be broken into 2 times 2, both of which are prime, so I circle them. And now I know I've come to the end of my prime factorization tree. The best way to write 24 in its prime factorized form is using exponents. You start with your smallest number that's circled, happens to be 2. And I could write it as 2 times 2 times 2 times 3. And that would be the right answer. But I think you're more sophisticated than that, so I'd like you to write it exponentially. 2 to the 3rd power times 3. And the way to check that would be if you plug this into your calculator right here, you would see that that would equal 24. Okay, and here's someone to celebrate your success. Here he is. Kind of not that big of a celebration. Okay, so now we're going to look at one that's a little bit harder. 120 has just a few more factors, and there's 2 ways to go about doing it. So I'm going to take the first way. I'm going to do 12 times 10. So, I'll take 120 and I'll separate it into a tree that is 12 times 10. Neither of which is prime, so I'll take 12 and separate it into 6 times 2. 2 is prime, but 6 is not. 6 becomes 3 times 2. All of those are prime. Now I've got to come over to the 10 because that's not prime. 5 times 2. Both are prime. And then I rewrite it. 2 to the 3rd power because there's 2 times 2 times 2. And my next number would be 3, so dot for times 3. And my next number would be 5, dot 5. And that would give me 2 to the 3rd times 3 times 5, which is indeed equal to 120. Another way to do it would be to have a different starting point. What if I had 60 times 2? 60 times 2 gives me 120, and 2 happens to be prime. Then I take 60 and I break it into something else. You have lots of choices here. I'm going to do, 6 times 10, neither of which is prime. So I keep going. 3 times 2, both are prime. 5 times 2, both are prime. And then I write my answer. 2 times 2 times 2, or 2 to the third. 3 times 3, and 5 times 5. Notice how I got the same thing, which means that I did it right in both cases because they both need to equal 120, and they do. In this chapter, you start to do it using variables, as everything is in 7th grade. So first, let's do a little celebration for us on our 120. Here it is, ready? Make sure I do it right, and very exciting, I know. Okay, our last problem here is going to be 45xy to the third. So I'm going to go ahead and use my pen, and I'm going to take 45 and I'm going to break it into 9 times 5. 5 is prime. 9 is 3 times 3, both of which are prime. And I'm going to write my x as x and my y to the third as y times y times y. Those are considered prime because you can't write them as anything but that or that times 1. So the way I would do the prime factorization of 45xy to the third would be 3 squared times 5 times x times y to the third. So the variables really don't present too much of a problem right now. That would be the prime factorization for that. And just to add a little bit of flair and fluff to our presentation, let's have a little celebration. Here it is. We're done.